Hello everyone, welcome back. This is 11.7. So I'm going to go ahead and have you guys go on here, or actually I'm going to go on this website just so that you can see how I would be seeing this as a student myself. So you're going to go ahead and go to joinpd.com and you would enter this code, sorry. So it's VXXRU. And then it just automatically connects to yours, and then it's going to ask you how you're feeling today. I'm going to go ahead and start the class. Okay. So today we are going to go ahead and do 11.7 surface areas and volumes of cones. Our goal is to find the surface areas of right cones, specifically find the volumes of cones, and then use volumes of cones for real life applications. So we're going to go ahead and just jump right into it. So the surface area of a right cone is given by this formula. We have that the surface area, again, so in this case, let me go ahead and explain a little bit. The surface area is everything that we can touch. So assuming this is just like think of it as a regular ice cream cone. If you were to just put your hand in every single aspect of this cone, that is the surface area that we are talking about. So here the surface area S of a right cone is given by pi r squared plus pi rl. Here it's pretty much the base, right? It's pi r squared plus the part over here on the outside of it. So it's pi, the radius here, and then L, or sometimes it's just denoted by the letter S. It's just the side of this cone here. And then, so basically, again, what I just said, where R is the radius of the base, and L is the slant height. Okay. So now I have this link up for you guys so that you can go ahead and explore on your own. It's I'm going to go ahead and click on it, and it's all about the cone here. So just some really cool facts, and it's just showing us how it spins around and how you can see everything around it. And here are some interesting things about the cone. It has a circle at one end, which is this one here. It has a point at the other, which is this part, and has a curved side, so this part here. And then it is not a polyhedron as it has a curved surface. So technically we call this the apex. This is just the base, and here it is. You see how it forms a cone by rotating this right triangle. So this is where the name comes, a right cone. So a cone can be made by rotating a triangle, which is really interesting. It's really cool to be able to see it. The triangle is a right angled triangle, and it gets rotated around one of its short sides. The sides it rotates around is the axis of the cone. Now here we have a few more things. A right versus oblique cone. So when the apex is aligned on the center, which is right here, of the base, it is a right cone. Otherwise, it is called an oblique cone, which is pretty much just a slanted version of the right. And then we have at the surface of the cone, again, it has its two parts. So it's the base, which is this part here, and it's again noted by the area of a circle, so pi r squared. And then the side area, which is this part here, and then it's just pi r times s. Okay. So which together it makes the surface area, so pi times r plus s. In this case, they just took out the r here, but you're basically just redistributing it. So here are some examples of that they give you. And so we're just going to, it was just a quick little exploration that I thought you guys would enjoy. So we're going to go back and we're going to go ahead and do an actual problem. So find the surface area of the right cone. So here we have our formula. We have S is equal to pi r squared, again it's this part, plus pi r L. Here we're just going to go ahead and plug everything in. We have our radius, we have our L, or our small s. Sometimes I notice in your textbook it's the L is the small s. And you're just going to go ahead and plug everything in. And just a quick reminder that when you are calculating these problems, you're always using the pi function on your calculator. So before, earlier in geometry, we had been using just a 3.14 to make the calculations, but now that we're actually trying to get a little bit more precise and accurate, we're only going to be using the pi function or the pi button, so just make sure that you guys do have that. Otherwise, it's going to be slightly off. So in this case, our answer was rounded off to 125.66 square inches because its area, it is square. Now, last time we were working with volume, and so that was cubic. So just making sure that you guys are aware of the differences between these two, and then just how that affects the measurements. Okay, so now we're going to go ahead and move on to the volume of a cone. Now, the volume of a cone is, so it's a third base times height. Now, the base is pi r squared, so we're going to just go ahead and substitute that with base. So it's technically a third of pi r squared times h, where b is the area of the base, h is the height, and then r is the radius of the base. So it's pretty much what we see here. And these are two different types of cones. We have the right cone, and then here again we have the oblique cone. So volume of a cone is again a third pi r squared h. So if they give us that the height is 7 and the radius is 2, all we're doing is just pretty much plugging everything in there. This is all algebraic stuff, so it shouldn't be too bad. I think you guys are going to have a pretty easy time with this, just as long as you're being careful with just, for example, placing the numbers where they belong, squaring what should be squared, and then just making sure you don't forget any little thing, as I feel like that would be a reason to get something wrong. Okay, so pretty much we plugged everything in, we squared what needs to be squared, we leave the pi at the very end, so we have 28 over 3 pi. Again, you're using your pi button in your calculator, and then you end up with about 29.32. Now, in this case, they didn't give us any units, but just normally you are going to be giving units, so make sure we're looking at that. Okay, so now there was this YouTube video for more information. I'm just going to go ahead and click on it, and we're going to just check out a few minutes, just so that you can see what would be on it. It's a pretty short video, but it's just the volume of a cone. So I'm going to go ahead and make this bigger.
Let's begin and perform step number 1. There we go, 1/3 pi r squared h. Let's take a look at what we got. Well, we got the height here, 30 centimeters, and that goes right there. We have the radius right there from the center to the edge is 9 centimeters, that goes right in there. Let's drag and drop them into the formula.
Okay, so he's just pretty much doing everything for you right there. It's just so you can see.
Remember to square it, yeah? And the height, 30. Let's plug them in the calculator. So 1/3 times pi times 9 squared times 30 altogether gives us a volume of Now we need it to the nearest centimeter cube, so we're going to need to round which way? Up, right? Because it's 0.69. So let's round it up to the nearest centimeter cube. The total volume and content and capacity in this solid is
Take a minute to check out our website at.
Okay, so that was just a video of him going over step by step the a specific problem, just so that you can see exactly how he was doing it. But I don't want to go there again. And so, yeah, that was pretty much everything that we've been doing, just making sure, again, in his case, he rounded off to the nearest whole number or whole digit. Again, that would be something that you would need to make sure by asking your teacher, reading carefully the instructions. Normally, they will tell you where to round it off. So either the tens, the hundreds, or the whole number. Okay, so here's another one. It says find the volume of the cone. This is going to give you an opportunity to go ahead and try this one. So I'm going to go ahead and try this on my phone just so that we can see how it would look. Okay. Okay, and so let me show you what I have so far. So I pretty much just wrote the formula, 1/3 pi r squared h. I substitute everything in there. And then this, as a teacher, it gives me an idea. Even if they didn't give the exact answer, it shows me how they're doing and what they're thinking it when they are solving this process or this problem. So I really enjoy this part. So then we would go ahead and move on and then just explain thoroughly step by step what it is that we did. So we have the volume equals 1/3 pi r squared h. All we're doing is plugging everything in, which is the two numbers here. And then we get 22.81 cubic centimeters. Okay. Okay, so at the end of this problem, I just want you to go ahead and kind of circle, see how you are feeling about this. Sometimes I get a combination of 2 or 1, so something like that. Okay. So now we're going to use the volumes of cones, find the volume of a similar solid. So cone A and cone B are similar. Find the volume of cone B. So I'm going to go ahead and move on. So the very first thing is we need to find the scale factor, right? Every time that you see that, whether you're being told that they are similar, you know you're going to be looking at proportions or setting up a proportion of some kind. So the first thing is we want to look at the scale factor of the radiuses. So we look at the cone, so the after and then the before. Or technically this is the pre-image and that's the image. So it would be 9 over 3 equals 3. So that means if I'm moving from here to here, it's it's obviously getting bigger and it's multiplying by 3 for the radius. Oops, not that way. So now I'm going to use the scale factor to find the volume of cone B. So now I'm going to be comparing the cones. So cone B over cone A. So I'm not sure what cone B is, but I do know the volume of cone A. So it's that's going to be my scale factor here. So it's going to be volume of cone B over 15 pi equals now my scale factor. My scale factor was 3, and then when I'm talking with or when I'm dealing with a volume here, then it's going to be tripled. So I have to make sure that I am tripling that as well. So then I'm going to just go ahead and solve for the volume of cone B, and I end up with so it was 405 pi. When I go ahead and plug the pi in there, I get 1272.3 cubic feet. Okay, and so now we are pretty much almost done here. And then I want you, I would give you just a little bit of time to go ahead and really reflect upon the things that we've learned today. Draw or type 2 things that you learned today. So I'll give you a couple minutes to go ahead and do that one. Okay, so I'm going to show you what I've done, and pretty much this is what you have. You can either type it, or you can draw it, or you can do a combination of both, which is what I did. So here I found the formula for cones, pi r squared times h, and then I just drew my cone, and then it's pi r squared h, and that's just one of the things. Obviously, the more you have, the better. But even just being able to have the students draw something, it will just make it where they are they're really thinking about it, and they're really processing it that much more. And it just gives you an idea of what it is that they've learned. Okay, one more thing, it's a reflection on today's activity. So what did you like, what didn't you like, what was easy, and what was hard? Now in this, it's the same thing. You can either type it up, or you can write it like I did. And so it's just an opportunity for the students to tell you how they're liking the lessons that you're doing. And they're really going to be honest, and they're going to tell you all the things that they liked. And maybe if some feedback, maybe it was I went a little bit too fast, or I could have gone over some more examples before I had let them try it on their own, which is a lot of the feedback that I got the very first time I did this. It was more of them just being able to see some examples done prior to me giving them examples to try on their own. So again, this is a pretty really, really cool format. I really enjoy this presentation session, and I think that anyone can do it as long as you have internet, and you can do it pretty much anywhere. So this was pretty much it for today, guys. I hope you did well, you liked it, and I will see you guys for the next time. Bye.